chapter is a introduction to organic chemistry. Organic chemistry is a big field all in itself. So we're just doing a very minor introduction to it, a very small introduction to it. We want to be able to name and identify some small organic compounds and name and identify some functional groups for organic compounds. Organic chemistry is dealing with carbon-containing compounds. And a lot of carbon-containing compounds are biomolecules, compounds of life. But then there's also a lot of compounds that we find in petroleum that aren't biomolecules, but have been derived just because they are derived from the processes of organic chemistry from what used to be life forms for petroleum. So hydrocarbons are compounds that contain only hydrogen and carbon. So hydrocarbons is a subset of organic compounds. We distinguish a number of compounds, so whether they are saturated or unsaturated. We see this on our food products for the vegetable oils that are present there. Saturated means that we only have carbon-carbon single bonds. Unsaturated means that we have some carbon-carbon double bonds or triple bonds. In terms of saturated, the basic compound would be an alkane. This is a hydrocarbon that contains only carbon and hydrogen, and all the carbon-carbon bonds are single bonds. So alkanes only have single bonds for our carbon-carbon bonds. A normal alkane, which is a straight line of carbons. Carbons form wonderful chains, and these chains can be straight or branched. So a normal hydrocarbon is a straight, unbranched chain of carbons. And all the carbons are full of hydrogen, so there's no double bonds. And straight chain doesn't mean linear. There's a bond angle of 109 degrees between every carbon, so then the chain can roll around, take different shapes in the process, so it's not just a straight, even though it looks straight when you write it out on paper. So, for the first 7 carbons, we have our names here. So the beginning of the name lets us know how many carbons are present. The end of the name, ANE, means it's an alkane. That means a saturated hydrocarbon with no double or triple bonds. So with one carbon, CH4, that would be methane. And we'll see the term meth show up on other things when we're dealing with one carbon. Ethane is 2 carbons. Propane is 3. Butane is 4. Pentane is 5. Hexane is 6. Heptane is 7. So on all these also, the number of hydrogens is going to be 2 times the number of carbons plus 2. So if we look at pentane, 5 carbons, 2 times 5 is 10, plus 2 is 12. So we have 12 hydrogens on that. There's number of structural isomers. This is the different ways that we can rearrange the carbon chain. So methane, there's no rearrangement possible. Ethane, 2 carbons, there's no, it doesn't matter which one comes first. Propane, there's no way we can get a 3 carbon chain. That's it. There's no other combination. But for butane with 4 carbons, we can have 4 carbons in a straight line, or we can have 3 carbons in a straight line with a 4th carbon coming off the middle carbon. So now it's a branched chain. So we get our structural isomers by making branched chains. And the number of isomers get big fast. And for these isomers, like hexane, we have 5 isomers. They're all C6s. So we can sell them as, we can call them hexanes. They are all hexanes. They have 6 carbons. But when we do proper naming on them, the proper name will be determined by the longest single chain of carbons. So then, among these 5 hexanes, a number of them are going to have other names that will be like propane, butane, with a side chain attached on also.